Okay guys, this is on section 4.8, part 2, page 113 in your student journal. So the first thing we're looking at is a local maximum. The local maximum is the y-coordinate of a turning point when the point is higher than all nearby points. So let's say I have a function like this. Right here, the y-coordinate right there, that would be a local max. And this point right here, where this y value is, this is going to be a local min. And this point right here, this is also going to be a local max. When we say the word local, we're just saying that compared to the points right around it, that's the high point. Local min, compared to the points right around it, that's a low point. But this is not the lowest point of all, because this function keeps going down. So this is just relative to the points right around it, it's a local min. Okay, so it's basically just going to be the high point and the low point, and it's always going to be just the y-coordinate. Even functions, these are always going to be symmetric. And I'm going to abbreviate with respect to the y-axis. So an even function that we know, y equals x squared. That's an even function. Do you see how that is symmetric with respect to the y-axis? So let's say I'm looking at this point right here. This point is 2, 4. What is this point over here that's a reflection over the y-axis? -2, +4, right? So when we have an even function, that means when I plug in a negative for the x, I get the same y value. Plugging in a negative for x gives us the same y. Odd functions look like this. Here's an odd function, y equals x cubed. If I plug in the point 2, 8, and I reflect down to here, what would this point be? It's actually -2, -8. So for odd functions, these are going to be symmetric with respect to the origin. Here's the origin. When I reflect it over the origin, when it's symmetric with respect to that, then I get this point. So this is saying when I take this 2 and I now make it a negative, my output is the opposite. When I put in -2, I get out -8. Tim? True. Yep. Y equals -x will be another odd function. Yep. All right. Let's go over here now to page 115. And here's more explanation of even and odd functions. So this says a function is an even function when f of -x equals f of x. The graph is also symmetric about the y-axis. A function is an odd function when f of -x equals -f of x. The graph of an odd function is symmetric about the origin. And here it shows us an even function. We put in a -x, we get out the same y. And here's an odd function. When we put in a -x, we get out the opposite y. All right, so we're going to look at some examples now. Describe whether the function is even, odd, or neither. Here's the first function. F of x equals -2 x to the 6th plus 5x squared plus 2. So I have to test f of -x. -2 stays the same, but wherever I have an x, I replace it with a -x. See how there's where my x's are. I'm replacing it with -x. So what's a -x to the 6th going to be, positive or negative? Positive times -2 would give me -2x to the 6th. X squared is positive times positive is positive 5x squared plus 2. Did I get back the exact same y that I started with? I did. So when that happens, when I plug in a negative x and I get out the same y, that means it has to be an even function. Also means it's symmetric with respect to the y-axis. So if I were to graph that function, I'm just going to do it real quick just to show you. If I put that in, it should be symmetric with respect to the x-axis. See how it is symmetric with respect to, I'm sorry, did I say x-axis? I hope I said y, because y is what I meant. All right, number 2, we're going to check this one. Yeah, Jen. Well, but what if this was to the third? Then it would change. See, like this one, or actually the next one we're going to do, this is odd and this is odd, but it's not going to end up being odd. So there is something you could look at with that, but you have to look at the exponent of every single term. In fact, what is the exponent for 2? 0. Is 0 considered to be even or odd? Even. If every single exponent is even, then it's going to be an even function. So what about on this one? Is this exponent going to be even or odd? This one's even, but what's this? An odd. So this is going to end up being neither. But just let me show you algebraically why. So if I asked you to prove that it's neither, I plug in a negative for x everywhere I see it. So a negative cubed is negative times negative is positive. A negative times positive is negative. So now looking at this output, is this y output exactly the same as this one? No. Did every single sign change? Is it the opposite of what I started with? No. So neither one happened. So this is neither. This isn't even or odd. And based on what Jenna was saying, how that's odd, that's even, it should be neither. So what do you think this one should end up being? Odd. Just let me show it. F of negative x. If I plug in a negative x to the fifth, what's that going to be? Negative times negative is positive. Negative x cubed is negative times positive is negative. Can you see how my output is exactly the opposite? So it basically is multiplied by negative 1. So therefore, that means it should be an odd function. Now, I also could have looked at this by just graphing my original. If it's an odd function, it should be symmetric with respect to that origin. So here I go. I'm going to look at this. It should be symmetric. See how it is symmetric about the origin? Okay, so therefore I know it's odd as well. All right, let's go over here. All we're going to do is number 2. This is going to be a little different than the other types we've done. You're only going to have to graph 2 of these on your homework, and I want you to use your graphing calculator for the whole thing. Okay? The reason why is that we're not going to have many easy roots on these. They're going to have very difficult roots. By that, I mean they're not going to be rational. A lot of them will be irrational roots. So we're just going to go in our calculator. We're going to put this in. I did give us a hint that x equals 5/2 is a root, but that's still not going to be enough for us to really be able to graph it without the calculator. So we're going to use the calculator, try zoom 6, see how that works. Not very well at all, because the graph is going way down here. Let's talk about the end behavior. If we have an even degree and a positive coefficient, what's true of the end behavior? Up on both ends, right? It's up, up. So I know that's going to happen. So I know that the graph is not coming back down. That's going way up there. So I'm going to go to my window. I am going to make my y minimum a lot lower because I want to see the bottom of this graph. That's a lot better. I'm actually going to make it go up higher too. I want it to look a little better. All right, so let's look at everything we have to find now. We know the general shape. It says graph the function, identify the x-intercepts. Well, we already know one of them. I gave you a hint on it. One of them is going to be 5/2. What's another one going to be? What could I factor out of here? X. So if I take out an x, I'm left with this. Okay, so what's my other 0 then? 0. How many other zeros should I have? 2. Now, this one, what do you think this one is right here? That's the 5/2. That's the 0. Is 0 a 0 twice? It looks like it from the graph, but is it from the function? No. So here's what I'm going to do. I'm going to go y equals, I'm going to put in y equals 0. So what's happening in, there's another 0 over here that's super close to 0, and I got to find it. So I'm going to do second trace, calculate, intersection, and I want to go over here just slightly to the left because the 0 that I want to find is not 0. So I do enter, enter, enter. And there's another 0 hiding over there at approximately negative 0.438. I want you to always go out 3 decimal places. Here's why. Our book usually goes out 2. When you take the AB calculus test or BC calculus test your senior year, every estimate is always rounded to 3 decimals. So you might as well get used to it. All right? Right here, here's another 0. We're going to get close to that. Enter, enter, enter. X is approximately negative 4.562. What if I needed to know what these zeros were exactly? If I asked you exactly what are those zeros, what would I have to do? Would you just not have any idea of how to find them exactly? Quadratic? How would I do the quadratic formula though? You've got it. Look guys, I could do 5/2, I could do my synthetic division. So I'm going to do my 2, 5, negative 21, negative 10. I would bring this down and I would get 2. I multiply, that's 5. I add, I multiply, that's going to be 25, I add. That's going to be 4 divided by 2 is 2 times 5 is 10, I add. Okay, so here's what I'm left with then. So this is my constant, this is my x, this is my x squared. So I'd have 2x squared plus 10x plus 4 equals 0. How can I find those exact zeros now? Do what? Quadratic formula. So I could do negative b plus or minus the square root b squared minus 4 times a times c all over 2a. So now I'm going to have negative 10 plus or minus 100 minus 32, 68. 68 is going to be divisible by 2. It's 2 times 32. It's 4 times 17. 4 times 17. So it's negative 10 plus or minus 2 radical 17 over 4. So that's how I could go about getting those real zeros. I'm not going to ask you to do that, but I just want you to understand that you could. All right, so back to here now. So we're trying to graph this. So we have our zeros at 2.5, at 0, at negative 0.438, right there. It's kind of hard to get it in there. 1, 2, 3, 4.5, right about there. Okay, now I want to find out what this minimum point is. So to do that, I have to do second trace, calculate a minimum. And we're going to have to go on the left side of it. So the left bound, that's on the left side of it. I have to go on the right side of it. And one more time. And there's where my minimum is. So I'm going to jot that down up here. So I have a min at negative 3.336, negative 138.272. There's where I have a min. I have a relative max right there. So I have to get on the left side of it. I have to be on the right side of it. And so I have a max at negative 0.223, 1.135. And then I have another minimum. And my other minimum is at 1.684, 36.431. Everybody with me on that? Now, when I'm going to go ahead, here's my zero. I kind of got stuck in there. When I go to graph these points, like negative 3.3 is there, negative 138, I want it to fit on my graph, so I might want to go like 30, 60, 90, 120, 130 right about there. I'm doing 30 on the axis here. Just going to make a note of that. Negative 30, positive 30. Okay, so then 36 at 1.6, and then I got to go up to 36 right about there. Was this a negative? No, it's positive. Never mind. This was a negative. Get rid of that. Got that point. And then this maximum is at negative. It's right in between these two. And it's just up barely, a tiny little bit. All right, so here's the way the graph is looking then. All right, make sense? Lots to find there. Now, if I ask you what is the minimum, you should really just give this, but I wanted to have the actual points. But the y values are truly called the minimums. These two would be the minimums, that would be the maximum. But watch what I have to do next. Determine the intervals for which the function is increasing or decreasing. Well, I would have to say the function is decreasing from negative infinity to this x-coordinate, which is negative 3.376. My function is increasing between negative 3.376 and this x-coordinate, which was negative 0.223. And then it's decreasing, this is a bit of a tedious task, decreasing between negative 0.223 and this x-coordinate, which is 1.684, and finally it's increasing again from 1.684 to infinity. You guys get the idea there? That is why I'm only giving you 2 of those. Originally we had like 5 of those assigned, and that's too much. It takes a long time to do these. But you do not have to come up with the exact zeros. You just need to come up with the approximate zeros, the maxes and mins, the graph, and the intervals of decrease and increase. And if you feel like you understand that, you know, just maybe practice finding the things that you need a little practice on. Okay? Oh, back to last question. Is this even, odd, or neither?
Neither.
Neither, right? It has no symmetry, so it's got to be neither. And plus, these are a combination of odd and even exponents, so it's neither. All right, good job, guys.